Alrighty, here we go with our next lesson. This time we are going to do something very unique, and we are going to kind of put some things together, so be ready for this. But today or tonight, what I want you to watch and kind of work with is we are going to compute with scientific notation. And of course, we're going to do this because nobody likes to work with large numbers. I mean, could you imagine having to multiply, 3,276,000 by 4,538,000? You're going to have to, it's a lot of numbers and a lot of zeros that you're going to have to write down, and your paper is going to be filled with those things. But instead, maybe there's an easier way of doing this. And in reality, there is. So I want you to take a look at this, watch what I do. I'm going to give you some problems again, and we'll see how you handle with computing with scientific notation. So let's take a look at our first problem. And the first problem we are actually going to look at is this. 3.5 times 10 to the 6th times 1 times 10 to the 9th. So this is just a simple problem talking about, what if I had 3.5 times 10 to the 6 ants? And if there are 3.5 times 10 to the 6 ants per acre in the Amazon rainforest, if the Amazon rainforest covers approximately 1 billion acres, find the total number of ants. Well, we don't want to have to multiply all that out. But here's the neat thing. If I use the associative property, and since this really is all just multiplication, because drop the parentheses for a second, it's 3.5 times 10 to the 6 times 1 times 10 to the 9th. I can redo this to be 3.5 times 1 times 10 to the 6th times 10 to the 9th. Well, 3.5 times 1, well, we know that's just 3.5. 10 to the 6th times 10 to the 9th, aha, it's multiplying two powers that have the same base. And we know when we multiply two powers with the same base, very simply we add the exponents. So what I find out is that there are approximately 3.5 times 10 to the 15th ants in the Amazon rainforest. I'm never going to the Amazon rainforest. So let's take a look at another problem, and let's work this one out together. 4.62 times 10 to the 5th times 8.15 times 10 to the 9th. Now, what we just did with the multiplication is we know that we can multiply the numbers, the decimals together, and then we'll multiply the powers of 10 together. So I guess the first thing we have to look at is this 4.62 times 8.15. And of course, we'll quickly do that. That's a 0. And that's 31, carry the 3 there. That's going to give me 23. We'll put a placeholder, 2, 6, 4. Double placeholders is 16. That's 43. That's going to be 36. And that's 0, 3, 15, 10, 7, and 3. And then 4 decimal places, 1, 2, 3, will be 37.0530. Uh-oh, that causes a problem, and it causes a very unique problem because it is not in scientific notation, because that's not a number between 1 and 10. So obviously I'm going to have to move the decimal over one place, causing another times 10. So I get my 3.7. I think I made a mistake there. 3.7053 and times, we know this ended up being times 10 to the first. So it's 10 to the first, 10 to the fifth, 10 to the ninth, which will give me 10 to the 15th. No, I didn't make a mistake. So there we go. So let me give you one to try here and see how you do with this problem. So I would like you to try 7.53 times 10 to the negative 8th times 2.93 times 10 to the negative 3rd. Pause the recording and try this problem. Okay, if you did this one correctly, you would have come out with the answer of 2.20629 times 10 to the negative 10th. Again, you would have come up when you multiplied the 7.53 and the 2.93 with 22.0629, which you would have had to move the decimal over 1 to give you the times 10 to the first, which is why you have 10 to the first times 10 to the negative 8th times 10 to the negative 3rd, which will give you that 10 to the negative 10th. If for some reason you get a problem like this, and I want you to try this, 6.4 times 10 to the negative 5th times 12,000. Here's my hint to you. It's easier if you convert 12,000 into scientific notation. Pause this recording and see what you get. Okay, if you did this right, if you figured this out, hopefully you got the answer of 7.68 times 10 to the negative 1st. So multiplying is pretty simple. What happens if I have to divide? What happens if I get 7.56 times 10 to the 8th over 3.15 times 10 to the 3rd power? Now, if you did this correctly, again, we're going to notice something very strange. It's multiplication and division. But one of the things I can do is take the division and separate it out, and take the multiplication and separate it out. And so now if I do 7.56 divided by 3.15, what I end up getting there is 2.4. Here, because I'm dividing my powers, remember when you divide powers, you subtract the exponents. So this will give me 10 to the 5th power. And again, I'm going to do this way. I'm going to do 7.56 divided by 3.15. And I'm not going to go through all that with you right now, but you can work that out. But that's how I would have done the division. Let's see. You try this one on your own, and let's see what you get. 4.62 times 10 to the 5th over 1.4 times 10 to the negative 9th. Pause the recording and try this problem. Okay, did you do it? Did you get the right answer? Well, let's see if you did. If you got the correct answer, you would have taken the 4.62 and you would have divided it by 1.4, and you would have actually come out with 3.3. Then you would have done 10 to the 5th divided by 10 to the negative 9th. Again, we'll subtract the exponents, so that's going to be 5 minus negative 9, which is really 5 plus 9, which gives me 14. Did you get 3.3 times 10 to the 14? Yeah, I thought you did. So now we get to an interesting one. And this is adding and subtracting with scientific notation. This one is the one I was talking to you about a little bit in class to be prepared for. See, if I have 5.45 times 10 to the 3rd plus 3.12 times 10 to the fourth. I actually just can't add those together. This is like variables. They have to be like terms. And in this case, they're not even close to being like terms. So I have to make them like terms. So I have two choices. I can turn one of them into 10 to the third, or change the other one into 10 to the fourth. Well, I think what I'm going to do... Okay, sorry, I got interrupted there for a second. So what I'm going to do is I think the easiest thing to do is go to the lower exponent in this case. So I'm going to actually take and convert 3.12 times 10 to the fourth into a 10 to the third. Now, if I want to do that, this really becomes 3.12, oops, let's make that a 2 there. A 3.12 times, I want it to be a 10 to the third. Well, how could I turn a 10 to the fourth into 10 to the third? Well, simply by multiplying it by 10 to the negative first power. And if you think about taking this and this together, well, that just makes this, and we'll write it all out again, a 5.45 times 10 to the third plus 31.2 times 10 to the third. Because the negative 1 tells me to move the decimal one place to the right. Well, now that I have that done together, I have two terms. And now this is going to be a little bit kind of thought process of remembering the reverse distributive property. And what I'm actually going to do is I'm going to, and if you remember the term factor out, I'm going to factor out the 10 to the third from each of those terms, which leaves me with a 5.45 plus 31.2 times 10 to the third. Well, now I could just add those together. And when I add them together, I get 36.65 times 10 to the third. Yeah, you caught me. I should have gone to 10 to the fourth in the first place, because now I have to turn this back, moving the decimal, which gives me the added 10. So really the answer is 3.665 times 10 to the fourth. You know, you never know which way you really should go on this. You just have to play around with it. Sometimes you'll get it easily and sometimes you may not. Okay, let me have you try this problem. 1.7 times 10 to the 7th plus 6.25. Let's rewrite that to be correct. 6.25 times 10 to the 5th. Okay, so pause the recording and see what you get. Okay, all right, so let's see. If I want to do this one and make this one to the 5th, for example, I'm going to make this 1.7 times 10 to the 5th times 10 squared. Well, that means I got to move that over twice to get 170 times 10 to the 5th plus the 6.25 times 10 to the 5th. Well, that ends up giving me a 176.25 times 10 to the 5th. Well, obviously I can't have that. I've got to move that over twice, which is another times 10 squared, to get 1.7625 times 10 to the 7th power. And there you go. And that's how we add, and the same method is used for subtraction. So that concludes today's notes.